Battery Management System, that is BMS. The battery management system is a technology that manages and controls the batteries. The BMS, typical BMS consists of various sensors, actuators, controllers, algorithms, and the signals, lines, etc. Its main task is to ensure the safety and reliability of the battery system, provide the state informations required vehicle control, energy management, and take appropriate actions on the battery system when there are some abnormal conditions. Collect the terminal voltage, current, temperature, and other information of the battery pack and each cell in real time through a sampling circuit and use the embedded algorithms is the function of BMS. Also, the BMS estimate the battery state of charge, state of health SOH, state of power SOP, and remaining useful life RUL, and then output them to the vehicle control unit, that is a VCU, providing the basis for energy management and power distribution control of the electric vehicles. The basic functions of battery management system. The BMS include data collection, various state monitoring, safety protection, charging control, energy management, equalization management, thermal management, and information management. So these are the main functions. In the data collection, it obtain the working condition of the battery accurately and better implement the management. The BMS needs to collect the terminal voltage, current, temperature, and other information of the pack and each cell in real time through a sampling circuit. The another function is state monitoring. Battery is a complex and non-linear time varying system having multiple states that change in real time. A battery management system needs to estimate this of the battery pack of the individual cell based on the real-time collected battery data using the various embedded algorithms and strategies to obtain the battery states at each moment that include the state of charge, state of health, state of power, and state of energy, that is SOE, providing support for the real-time states analysis of the battery. The another function is the safety protection. The battery safety protection function mainly refers to the online file diagnosis and safety control of the battery system. The faults to be diagnosed in the battery management generally include over voltage, that is overcharge, under voltage, there is overcharge, over discharge, over current, ultra high temperature, short circuit, loose joints, reduced insulation, electrolytic leakage, as well as the faults of electronic components like sensors, actuators, and controllers. So safety protection is the important function of the BMS, and it includes various parameters, that is voltages, temperature, short circuits, and other mechanical faults. The next is charging control. Charging process of the battery directly affects the lifetime and safety of the battery. So if the battery is overcharged or over discharged, it may reduce the life of the battery. And also there may be some hazardous situation when the battery is not properly charged. And because of that, there may be rise in the temperature and there may be again the safety concern. Battery management system usually needs to equip a charging management module to control the charging of the battery according to the real-time characteristics, temperature of the battery, and the power level of the charger. The next is the energy management. In order to ensure the safe and economical operation of the vehicle, BMS needs to reasonably control the energy output of the battery and the energy recovery of the regenerative braking based on the collected battery data and real-time status information. So energy management is the important task. BMS needs to optimize the distribution of the respective energies according to the respective state information of the energy system. Next function is equalization management. Due to the errors accumulated in the production process, transportation state, and storage of the batteries and electronic components, inconsistencies are there between the cells also, which are natural. So in order to fully utilize the battery or the energy stored in the cells and ensure the safety of the pack, BMS adopt the active or passive equalization methods and it equalizes the cells, reducing the inconsistency of the cells. Thermal management. The next function is thermal management. Battery is not only affected because of the ambient temperature, but also affected by the heat produced during the charging and discharging process of the battery. BMS equips with the thermal management system or model to determine the intensity of active heating or cooling according to the temperature distribution information given by the sensors and charge discharge requirements in the pack or the cells. Therefore, batteries can work at a suitable temperature range and maximize the performance and extend the lifetime of the batteries. Next is the information management. The BMS needs to integrate multiple functional models and coordinate the communication between the models. BMS needs to manage and filter the data of the batteries, store critical data, and communicate with the network nodes such as the vehicle controllers. With the big data technologies, BMS also interact with cloud platform in real time to better handle the management problems of the battery and improve the management quality. Battery management system topologies or BMS topologies. The topology of BMS directly affect the cost, reliability, convenience of installation and maintenance and accuracy, that is measurement accuracy of the system. Generally, the battery monitoring circuit called as BMC and the battery control unit BCU form the main hardware circuit of the BMS. So BMC and BC, battery monitoring circuit and battery control unit are the important hardware circuits. According to the structural relationship among the battery monitoring circuit and battery control unit and the cells, the BMS can be divided into centralized topology and distributed topology. So these are the two types of the BMS topologies, centralized BMS and distributed BMS. All these types are, as discussed, are mainly based on how this BMC, battery monitoring circuit, and battery control circuit are placed into the overall system. A centralized battery management system topology or centralized BMS topology. Here we can see a centralized BMS where the BCU and BMC are combined there and each cell is connected directly to the BCU plus BMC and then it will interface to the vehicle controller, then the display and the charging pile. So cell 1 to cell N, they are connected. So centralized BMS is often used in applications where the battery has low capacity, low total voltage, and small battery systems. Centralized BMS topology is shown here considering this. The measurement signals of each cell are transmitted to a single PCB, that is a BCU and BMC, battery control unit and battery management, battery monitoring circuit and battery control unit, BCU. Advantages and disadvantages of centralized battery management system. The advantages of BMS, centralized BMS are high-speed intra-board communication ensures a synchronized data collection. Second, compact structure and strong anti-interference ability. The second is the low cost and all the work of the BMS can be completed using only one package. The disadvantage of centralized BMS as follows. It produces a large number of complex wires and connections. It is difficult to protect the battery when short circuits and overcurrent occur in the different parts of the system as they all are connected to a centralized BCU and BMC. Considering the high voltage safety, sufficient safety clearance must be kept between different channels, which eventually leads to the excessive size of the PCB. All components are integrated in a single PCB, resulting in poor scalability, extending more number of batteries and maintainability. So scalability is not possible. So addition of the cells is not possible here. A distributed BMS. Here we can see the battery control unit and battery monitoring circuit, the BCU and BMC are arranged separately. So as compared to the earlier configuration of centralized, here the BMC battery monitoring circuit and there is another which is the BCU battery control unit. So they are connected separately and each cell will have a separate battery monitoring circuit, that is the BMS. The BCU is primarily responsible for, that is the battery control unit. This is responsible for fault detection, battery state estimation, switch management, charge discharge control, and communication with vehicle control. The BMC is used to manage the cell voltage, current, and temperature, as well as security and consistency management. BCU and BMC are connected by a CAN, that is a controller area network bus, and any BMC can communicate with the BCU directly through this CAN bus. In addition, each PCB of the BMC belongs to a node of the CAN bus and is separately connected to the corresponding cell. Therefore, the communication can also be established among BMCs. That is the battery monitoring circuit. Advantages of distributed BMS. Since the function of data collection and calculation is separated, being the BCU and BC are separate, the fault is easy to check and the calculation efficiency is also very high. Second, the structure of system is simplified and layout is flexible and applicability is very good. The number of managed batteries can be increased or decreased by replacing or removing BMC PCB near the corresponding battery as there are separate BMC and BCU and connecting it to or unhooking the reserved CAN bus interface. So the scalability problem is solved here in distributed BMS. The disadvantage of this topology are the large number of components require more PCBs and steps of installation, debugging, and disassembly. It is easy to form a network delay and affect the synchronization of the collected data. The design requirements of communication network are hard to meet. So here you can see the functions of BMS in a cell and pack level for the current and future technologies. The current technologies, there is a cell level measure, diagnose, and monitoring, and there is a pack level monitoring and estimate. So here you can see the current technologies at cell level measure voltage, current, and temperature, and at diagnose level thermal control and cell control. In future technologies, there is also monitoring internal resistance, cell capacity, defective sensors, cell fault, thermal protection, and fail and safe status. At pack level, it is also connected to the cell level. So it has the monitoring of voltage, current, and temperature similar to the cell level, and estimate the state of charge, state of power, state of health, thermal management, and cell balancing. Also, it can estimate the state of function, state of safety, sensors for fault, isolating fault, cell capacity estimation, thermal protection estimation, and display the charge remained and charge discharge control.